Hi, everyone. Welcome to today's webinar. We are going to be discussing rural road design in West Africa using RoadEng Civil Engineer software. My name is Erin. I just want to thank you all for joining us here today. This is going to be a jointly hosted webinar by Softtree Technical Systems. We're the makers of RoadEng software based out of Canada, and our fantastic local partners in Nigeria, Keycam Technologies. So today we're going to be discussing the role of roads, how important they are, and then we're going to be really focused on a workflow inside of RoadEng software to enable you to do better quality rural road designs leveraging a geometric design software. So it's going to be a mixture of some PowerPoint content as well as some in-software content. Now for a little bit of a more formal introduction to the folks here on the call. With me today is Matthew Dickey. He is our training manager here at Softtree Technical Systems. He will be running the software for us and chatting us through a workflow. I'd also like to introduce Bonnie from Keycam Technologies. He is the vice chairman there and has joined us today to add some additional dialogue towards the end of the presentation about how you can get engaged and get learning with RoadEng. And then, of course, there's myself. I'm the business development manager here at Softtree. So thank you all again for joining us. We're really excited to have you here today. So today, our webinar, as we said, is going to guide you through the basics of RoadEng for rural road design. And we're going to guide you through key features and functions, but really have, say 4 key learning objectives that we hope that you're going to take away from the webinar. The first of which is we hope that you understand and sort of know the steps for a high-level workflow to be able to do a road design using RoadEng, whether that's starting with importing your topographic data, the alignment creation, all those core steps. So we're going to set you up with that workflow. We're also going to focus today's presentation on showing you how to import 2 different kinds of topographic data, and then build the resulting TIN model, which we'll explain a little bit more about what that is in a few steps. So first, we're going to start with an example that leverages total station data. And from there, we're going to do a second example that shows you how to work with higher resolution data, whether that's DTM data or DEM data, maybe it's LiDAR, maybe it came from a drone. We're going to talk a little bit about how do you work with that sort of more point cloud style data and bring that into RoadEng and again, create road designs. So those are our first 2 objectives. Our third objective is really to show you some of the absolute core steps, and hopefully if you picked up a trial, you could go and replicate them almost immediately afterwards, which is how do we create and edit horizontal and vertical alignments, and then how do you create construction documentation? How do we do output? So showing those core steps in particular. And lastly, our final learning objective for today really is the introduction of optimization tools. And yes, it's a buzzword, but inside of RoadEng, we have 2 very specific optimization tools that can really help improve the efficiency of your design, as well as, more importantly, reduce the cost of that road alignment through minimizing earthworks, and then being able to allow you to take more environmental constraints perhaps into consideration. So that's with Path Explorer AI, which is an AI-based road locating tool that we have in our software, as well as through vertical optimization. But again, more on those in the slides to come. So let's just take a step back and talk about the importance of rural roads. Rural roads are the most common type of road in the entire world. I think it's over 80% of the world's roads are rural roads. And in West Africa, over 60% of your population are living in cities and towns and rural areas, not the cities. And the rural roads are really that important and essential access to those communities. Rural roads connect residents, tourists, resources, goods schools, healthcare, you name it. And of course, they have a lot of secondary benefits as well. You know, in emergency situations, rural roads are evacuation routes. If you're in a part of the world that unfortunately experiences wildfires, rural roads serve as fire breaks. So today we're really, talking about what we think are the most important types of roads in the world, which are the rural ones. And with that, well-designed rural roads are really important. Of course, I'm sure everyone here is familiar with the type of rural road on the left on my slide. You know, a poorly designed rural road really can have a lot of negative impacts, whether that's to the speed of transportation, just even to the ability of some vehicle types being able to access it on that road. And there's obviously in poor road design and poorly constructed rural roads, there obviously is a role of water. And we'll talk a little bit about that today. So focusing on giving you tools that are going to allow you to better design rural roads, tools that are going to minimize construction surprises, going to minimize construction costs, and ultimately, as we show you today, the design you make is just a plan, but it's a plan that really does help you set the goalposts for that road and the expectations for the construction crews as they try to bring your design to life. So today, really, again, rural roads, so important, and we're going to focus on arming you with the tools in order to improve their design. Now, in order to get a well-designed, well-built road, we're talking about design software. And really, I think sometimes it's important for us as a software maker to step back and kind of look at the challenges that exist with design software. Is first and foremost, the design process takes a lot of time. And the fact that it's so time consuming sometimes can make it a barrier to design. So hopefully you're going to see today in RoadEng that we've really made a lot of effort to help simplify the workflows, simplify the steps, find efficiency tools that are going to help you to save time as you go through the design process. Design software also, unfortunately, has a tendency to be really complicated. So again, as we step through the software today, hopefully you're going to see that, RoadEng, again, reduced menu functions, lots of really straightforward workflows. So it doesn't have the same complexity that other software brings with it. And with that, it does not have the same steep learning curve. And the final challenge that we like to mention as well is that most design software tends to focus on the drafting, the little tiny CAD details, but doesn't help you look at the bigger engineering picture. And it makes it more challenging to consider different design elements, whether that is the water, the topography, the different soil types you're working with. So RoadEng really strives to focus on the latter, on the engineering decisions, and acts as a tool in your tool belt to help you achieve them. So with that, let's formally introduce it. This is RoadEng. RoadEng is our rural road design software. It is a really neat platform in the sense that it's integrating both 2D and 3D design elements into an environment that allows users to really easily import different types of survey data, adjust their alignments, get their volumes, mass haul calculations, and then lastly, communicate their construction plans. I should say we are really specialized, obviously, in the rural side of things, lots of different applicable project types throughout the world. And really, today's webinar is going to showcase two of them. So to start, we're going to go into our first demonstration. This is going to be leveraging total station data. So here we're going to import total station data, build a terrain model, calculate our alignments, and create our alignments, I should say, calculate our mass haul, and then configure output. And to help make it a little bit easier to understand the workflow, we're going to do a little bit of back and forth between my colleague Matt and I. I'm going to introduce the step. Matt's going to talk us through it, and we'll do that throughout our first example here. So step one of the workflow inside of RoadEng, which is importing your topographic data and creating what we call a TIN model. Now, a TIN model is shown here on the right side of the screen, and that stands for a triangular irregular network. A TIN basically, serves as that 3D model to represent your original ground or potentially your design surface, and allows us to actually do the road design. So we can work with a whole bunch of different types of data. We're going to start here with conventional data. So this is your total station, your RTK type data. And with that, I'm going to pass it over to Matt, and we're going to get into RoadEng, into the software. I'll let you take a look at that first important step. Matt.
All right, perfect. I'll share my screen here and we'll start right from scratch. So I'm going to just pop open terrain. So opening a new instance of terrain, we're going to click insert file, and I'm going to grab my Topo survey information. So in this case, it's just a text file. Could be, well, really anything. The important part here is that we have coordinates. So 3D coordinates. And then if we want to make our lives easier, we've also got some point codes and point numbers that we can use to help automate how that information gets brought in. So when I click open here, I'm going to just reference an IOP that's set up to match my survey format. You can save this and reuse it over and over again. We've got that set. We'll hit OK. And we see that we have, well, a series of points and lines. Now those points and lines, we can see them in the plan view now, but if we click the 3D view, we can also see that, well, they're 3D features. And we can take those 3D features and turn them into a tin surface with our contours at the click of a button. So with that, I'll pass it back to Erin.
Awesome. That was very quick, Matt. And we might need to go through that a little bit slower later again. But hopefully you could see just how easy it is to import and work with your data. So step 2, that was our terrain model module. And from there, we're going to head over to our second module, our location module. And this is kind of a funky step. So most people think when they go over to the second mini program or second module, they're going to go and press open and open their terrain file. So here we're going to go File, New File, reference that terrain surface that Matt's going to save. And then from there, we can get ready and set up with how our screen looks, set up our typical cross section, and get ready to start a new road design. So with that, I'm going to go back to Matt.
Awesome.
And we'll continue in the software.
All right. So as Erin stated, we're going to go from this terrain module to the other module, which is location. But we do want to have this surface saved. So before I switch over, I'm just going to hit save. We're going to save it as Topo. And I'm going to pop open location. And we are going to reference that Topo file. So we're not going to click open here. So in the location module, we're going to click new to start a new road design. But we're going to reference that Topo file that we have saved. So we're going to go in here and we're going to reference that. We'll hit OK. And well, when we start our design, we could just start with a single point and we could draw in our alignment. In this case, we could use a terrain feature instead. So I have a surveyed center line rather than using just manually drawing something in over top of that. We're going to use that existing center line as our starting point. We'll hit next and we'll hit done. Now right off the bat, get rid of that point that's falling off the edge of our model. But right off the bat, we can see that, well, we've got a few different views. And well, this view that we're looking at is representative of what I like to use when I'm designing. And you can set this up to, well, look however you'd prefer when you're starting out with the software. So if you wanted to have your plan view on that side, you could drag it over, move everything else wherever you'd like, customize hatching, etc. in your cross section. customize your data table or data tables to appear however you like. If there's a window that's not visible that you'd like to be visible, you can pop it open down here using the different icons. And once you had that information presented in the format you'd like, you could come up here and you could hit, well, view, screen layout, save, and you could save it as normal.dlt so you don't have to do it every time. Or you could save it as something else and you could very quickly switch over to it. So if we want to, get really fast at doing these types of projects and have everything just at a glance where it's natural for us to see it, it's certainly useful. Now, the other thing that we're probably going to do here is to be cognizant of what our cross-section geometry looks like. So here I can see my cross-section view, but I didn't actually change anything to make that cross-section look the way it looks. So that view is showing us the cross-section template that's applied. So I've got my default rural road template being applied, and the list of cross-section templates that we have to pull from is, well, controlled in the template library. So when we install the software, we're going to have 3 templates that we don't have to change anything or bring anything or edit anything in to have access to. So with these templates, at the highest level, the templates are largely a holder. So we have the options to customize things like your crown. So if you're worried about designing your road so they properly shed water, we can adjust the crown on that. We can give it a name, but the majority of the geometry is controlled by the components within them. So in here, if we wanted to say change our road width from a 7-meter wide carriageway, so ACP width 3.5 either side, to maybe a 9 overall, we could just change that and we can see that it updates in real time. We see the parameter, the impact of the parameter that we're changing and what that has on things. So we could totally go through this, basically acts as a fillable form that controls our geometry and our logic. And then if we had something that wasn't well represented by these 3 templates, well, we could go onto the E library and bring in a whole collection of components that we can use, and they're basically modular where we can copy and paste and move things around however we like. So if we wanted to do something like include a wall, we could just copy that wall component over into another template and we could assign that where we'd like. For this project though, this default rural road happens to be quite appropriate, and we'll just run with that. So we've got our project set up. The next kind of side of things will largely be in the geometry space. So I'll hand it back to Erin to introduce that.
Thanks, Matt. Okay, so we have, just to quickly recap, first step, imported our survey data, created a tin surface. Second step, created our new location project, referenced that topo surface, and set up our typical cross section as well if we had wanted to, configured the way our windows look. So now we get into the fun stuff. So in our third step of the process, we are going to create our horizontal alignment. Now, when you're working with Total Station, or in the future, as we're going to show you if you're working with something from Path Explorer, we have a tool called Polyline to Alignment. And what Polyline to Alignment is going to do, it's going to take that center line that we had surveyed and turn it very quickly into a proper alignment with curves. From there, everything in RoadEng, very, very editable, customizable. And we are going to go and show you how you can then manually edit and change your design. So what that alignment editing looks like. We've got an add edit tool in the software, and it's quite flexible, and it'll allow you to dynamically update any intersection points as you go through your design. And from there, we'll also apply horizontal curves if we've done any IP editing. So with that, let's go take a look at some of the different horizontal alignment creation tools, starting with Polyline to Alignment. And for that, I'm going to pass it back to Matt.
Alrighty, and we'll share my screen. So on this particular project, we had that surveyed center line that we wanted to use. So if we want to use that as kind of our starting point, maybe we're doing a road upgrade where we're keeping the road alignment largely where it is. Well, we could come over to the corridor ribbon. We could click polyline to alignment, and we could say, well, I want to fit curves with a minimum radius of 100 meters to this, instead of having to trace and manually add curves. And we could hit OK, and the software is going to think for a bit, and it's going to look to minimize the deviation from that initial alignment with the fewest number of curves. So here we've got our curves. It happens that, well, a radius of 100 fits really well here. And like that, we have a nice horizontal alignment that's a proper alignment to work with. And of course, we can edit this, we can move things around, etc. Now, just before I go too far in one direction, if we didn't have an initial alignment to work with, we could have set it up that we want to just start with a single point. And well, we could have had something like this. And just to hide that for a moment, well, if we didn't have an alignment to start with, we could come in here, we could say, well, I want to move this around, and well, we can see we've got two roads appearing here. As I clicked in that other alignment that we just did from scratch instead, we can see the ground profile underneath. And I won't get too far ahead of myself and start editing my vertical alignment. But if we wanted to add curves here, instead of automating it, we could come over to the horizontal curves panel, and we could say, well, at this particular IP, I want to add a circular curve. I could set my radius, my design speed. With that, if I have, well, advanced curves on, it's going to automatically assign my curve super elevation. If we wanted to add a spiral curve in there, we could do that as well, and it's going to give us that tangent runout length. So we could hit that, and we could cycle to the previous curve. We could hit that. We maybe want to go with something a little tighter here, 100 meters, let's say. And now we can move all of these around, and this is not unique to just designing it from scratch. So I'm gonna, clicking that in, really just showing how things behave. I probably want to use this alignment as my initial alignment. I'm gonna get rid of this just for the sake of only having one alignment in the file. But if we wanted to edit this beyond just using that, we could grab those IPs, move it around. Here I'm falling off my model, so we can pull that back onto the surface that we're working with. If we want to edit those curves, we can edit those curves, etc. So pretty easy to work with, pretty straightforward to work with. And I am going to straighten this out a bit, but I'm actually going to pay a little bit more attention to what I'm doing than those previous clicks. I'm going to make my curve a little broader here, and I'm going to make my curve a little broader here. And with that, that is the premise of editing our horizontal alignment. We have those IPs, which we can edit in our Edit IP tool mode. And then we have our curve panel where we can assign the curves. And if we have line work that we'd like to start with, we can take it from being a polyline to a proper alignment, which is curvilinear, so a series of curves and tangents, all at the click of a button. And with that, we'll pass it back to Aaron.
Matt, I might pause you before I take it back. There is a question that's, quite relevant, I think, to the section you're in right now, which is, where is it getting the road standards from, and can I update them?
That's a good question. So yes, absolutely. So I kind of in passing mentioned that it's assigning my curve super elevation. We have that being populated, and it's up to the user how it's populated, whether it's based off of a table or if it's using a side friction factor. Here I'm using a table. So this table is set up, it's based off the AASHTO standards. The user can either edit this one or make their own table to reference. So hit open, the extension is TBL, but a CSV will work as well. Just follow the format in there, save it as whatever you like, and you can reference it. So this idea of having a lookup table based off of, well, either default settings or your own standards is not something that you have to rework every time. And similar to how I introduced that screen layout functionality, you can save that information for future projects. So if we have our design standards set up, and we can define that here as well, and we wanted to save that and maybe our cross-section information, well, we could save that as a TPL file. So if I wanted to save all my cross-sections and all my road design standards, I could do that. If I save it over my normal.tpl in the default directory, that's going to be what appears when I open a new project. But we could very easily just save it as a new name and we could read it in. And if we open a pre-existing TPL file, it's going to replace everything that's in your current package. If you click merge, it's going to add those cross sections to your current project. And hopefully that answers your question. And with that, I'll pass it back to Erin.
Excellent. Okay, so again, quick recap. We've created our tin from our topographic data. We've created a new project. We've configured our cross section. We've set up our horizontal alignments. And of course, the natural next step now is to go over into the vertical side of the software. So here we're going to focus on showing you how to initially create your vertical alignment with the mouse. We'll show you another slick method in the second demonstration coming up in a few minutes. We'll also show you how to add vertical curves. Alongside this, it is, a bit of a topic we'll discuss as well in an upcoming step, but we will pay attention to the mass haul and leverage that as we're creating our vertical alignment. So back into the software again, let's now go take a look at how we create the vertical profile for our road design.
Alrighty, so where we've left off, and it's very similar to what we did in the horizontal. But right now, if we click along this alignment, our center line is set on existing ground. Now, if we wanted to have that with its own independent profile, not just setting on the ground, in which case we would want that the vast majority of the time, well, we'd come in here in our profile view. We'd right click, add a BIP, and here I'll add a IP at the end. So now we can see that these two, well, the ground profile and our road profile are very different. We're filling an awful lot right here, and we've got a little bit of cut right here. And we can see that that change is displayed throughout the software. Now, of course, we probably aren't just going from start to end in a straight shot. We probably want to add in additional curves, and we can do that. And of course, Erin alluded to it, but we can look at the geometry. We can judge that, and it's all connected. But geometry is really part of the problem. And we also probably want to make sure that our earthworks are going to be balanced or close to balance. So I'm also looking at this graph down here to keep track of that. Now, when it gets time to add in my curves, I'm going to add in my vertical curves. And we'll assign those. And here, well, I want to go a little longer with that curve. Let's go with a K of 32. Go a K of 40 here. I'll lift this up a hair. I see that now I'm not balancing. We'll drop it down, and we get very close very quick. With this, it's of course, we've introduced the subject as working with our vertical alignment. In practice, it's not usually just one or the other. You're usually making adjustments back and forth. So if I decided that I wanted to maybe adjust this horizontal curve that we've previously added, we could add that, move it around. I've only moved it slightly, so the impact is very minimal. But we can move it a bit more, so we can see that the ground line's actually changing, our mass hull is actually changing. And then if I want to just do something radical for the sake of really driving home that this is dynamic, well, we can pull it around and it changes a lot. So yeah, aside from just being easy to edit one element at a time, the fact that all of these elements are interconnected and dynamically updating makes it super user-friendly. And then lastly, before I pass it back to Aaron, I will just at least add a little bit of a teaser for where we're going with our second example. But if we didn't want to mess around with this, manually adding in VIPs and adjusting curves, well, what I'd probably do in practice here would be to use the vertical optimizer, where we can set our design standards and then tell the software to figure out where that vertical alignment should be given our road costs. But we'll cover that in the next example. This one's pretty small. We'll do a big example in a very short amount of time in the upcoming one. So I'll pass that back to Aaron.
Okay, continuing with our core workflow of steps. So from here, I'm now gonna encourage Matt to spend some time talking a little bit about how do we add culverts, and that's done through our culvert editor panel. Also taking a look at some of the general drainage elements that are included in our road design, because that's so important, whether that is the slope of our road, the crown, the ditching. We'll get Matt to talk a little bit about drainage. So Matt, that was a really fast flip for me. Thank you for getting us out to our vertical alignment. And now let's take a look in a little bit more detail about culverts and drainage.
Sure, and I'll take back the screen here. So if we want to add in a culvert, of course, the drainage elements of our design are super important. We can really quickly do that. So similar to how I was adding vertical curves and horizontal curves, we have a panel on the right here. So I've got my culvert panel. And for this, if I decide I want to add a curve at this, or a culvert at this location, I'll set my cursor on the station that I'd like it to be on. I'll click add, and we'll drop that into place. And here we can see that I've got a pretty small pipe being added in there. Maybe we go with a larger pipe. Let's go 2,500, if nothing else, just so it's a little easier to see what we have. And we can take that and we can adjust our skew. So if we want to make a slight adjustment to our skew, we can. If we want to make something larger, we can do that. And tabular input's really easy to see what's happening as we adjust. So we've got the skew relative to your center line. We can also adjust the pipe gradient. So if I wanted to have that at 1% instead of 2%, we can adjust that. If we wanted to change the length, so here I've got 22.65 and 24. Well, maybe I want that nice even numbers. We can update that and we can hit apply. And then if we wanted to say perch our pipe for some reason, we could do that instead of attaching it to the catch point. So let's say I want this down 2 meters, and well, it looks kind of funny. So let's move it back to the way we had it. But really easy to work with, really easy to put together a summary of that information if you like. We'll cover that later on in reviews. But that's one of the critical parts of your drainage elements. Now, other things that we could adjust, and I won't go into a ton of detail here, just hopefully cover enough to show the flexibility. But I mentioned that we've got, well, in here I've got that super elevation being applied. So let's go back a little ways. I've got my crown being assigned. So if I wanted to have it so that road is shedding water faster, we could come in here and we could bump that up to maybe being a 4% crown instead of a 2% crown. And there we are, much more pronounced. Now, of course, the other big drainage element in our cross section is going to be the ditches. So in here, I've got a fixed depth of 5 meters, or sorry, 5 meters, half a meter. And I've got a width of half a meter. If we wanted to make this a little easier to maintain, maybe we increase that bottom width to 3 meters. So really easy to make adjustments. And if we have things like, well, maybe we don't want to have what we have here where the ditch is following the road grade. Maybe we have something where we wanted to set the ditch profile independent of the road profile. Well, if we wanted to do that, we could use something like the ditch with vertical tie component, where we could define an alignment for our ditch, and we could grade that independently. Yeah, and really, I think those are the stereotypical drainage elements for a road, but there's all sorts of things that do play into your road's performance as it deals with water. Could be the pavement structure that you're using, the gradation of materials that you're using, could be the cut or fill slopes that you select in order to keep them maintainable or prevent raveling, blocking your ditch, etc. So all of that stuff is really easy to adjust from a user's perspective in here, and equips you to make better decisions. And then lastly, I won't do it with this example just because it's a fairly small area, but we have hydrology tools, which I'll introduce in the other example as well that leans into this. So with that, I'll pass it back to Erin.
The next step, now that we've got our alignment pretty much in the place that we'd like it to go to, we've got some of our drainage structures added to the road alignment. So from there, it's really all about fine tuning, iterating, and reviewing and reporting the details of that alignment. So here you can take a look at the mass haul in more detail. We can take a look at the different volumes and other information generated through data tables. And we can also take a look at our alignment costing panel. Matt, back to you.
Awesome, sounds good. Well, with alignment review, there's all sorts of different levels that we can consider that. And really, as you're designing, you're probably doing a lot of this in real time. It's one of the perks of using the software if everything's updating. So of course, part of that is just visualizing it, and we can see what we're dealing with in the plan view, the section view, the profile view, the 3D view. And I am a sucker for the 3D view. It becomes really easy to really capture what your project consists of at a glance here. Now, beyond just the visualization, and we kind of alluded to it, but we have this graph down here, which is our mass haul. I've been kind of clicking away here, and I've got it so it's not balancing, but this mass haul graph is tracking our surplus and deficits, and it's also typically going to be used to help approximate where our cut material is going to be used for fill material. So if we wanted to make some adjustments here and drop this down, again, we can see where that cuts and fill is going to be moved based off that graph. Now that's kind of a simplistic look at it, but it's nice at a glance. When we get into our optimization tools, the software has a much smarter way of tracking that material movement, and it's what's used in the costing and optimization side of the software. So beyond that, if we want to look at and consider how much our project might cost, we have ground types that can be assigned. So we can assign different subsoil horizons along the length of our road if we wish. So here I'll just keep it simple. We've got our defaults. And I'm saying that it's cost $12 a cubic meter to excavate, $4 a cubic meter to turn that excavated material into embankment. And then we have our material movement costs. So if I were to come up here and click recalculate recosts, I get this breakdown of my costs, so total costs for earthworks for the information that we've defined. And those numbers are updatable. You can make them reflect your local construction costs. But we've got this breakdown where total cost $460,000, cut cost $328, fill, 103, hull, etc. And we can customize what appears here in the summary as well. Now, the information that's driving that is a more complete hull breakdown. And it won't be that interesting here, but the software is actually using something more complex called the OptiHull, which gives us freedom if we have other materials that need to go different materials in different directions. It'll account for that. And then we've got just the plain old data table. I'll pass it back to Erin.
Okay, I'm actually going to cover how do we, now that we've finalized our design, how do we communicate this? And that's really the place where we like to use our multiplot tool. So multiplot is a construction documentation generator. And with it, you can create, really quickly and easily pre-populated construction documentation that you can share with your contractor, you can share with your clients, as well as a few other output options, such as their drive-through mode and an ability, if you've got other tools that you'd like to work with as well, we can go out through land XML format, DWG, shapefile if you're, say, an ArcGIS user. Yeah, lots of options. Very good. So we're going to go back to Matt.
So where we've left off, so this data table, instead of giving us a graphic of what we're up against along the length of the road, well, we can have this summarize whatever information we'd like. So here from station 7 to 100, I've got cut of 1,400 cubes, fill of 8. So we can step along and see the volumes between our stations. We could very easily add in a new data table. And if we wanted to, say, put together a data table that showed our culvert information, we could do that. So I could come in here and I could say, well, I'm interested in reporting information anywhere that we've added a culvert. And I'm interested in summarizing, well, where that is in terms of my station. And maybe I'm interested in getting a running tally of how many culverts by diameter and length. And if we wanted to, for staking out, we could put in the XY coordinates of XYZ coordinates of our inlet outlet. But it's really easy to put together a data table. So you can have lots of things automatically being tracked as you design. And well, aside from just kind of looking at it at a glance, if we wanted to jump in here and see, well, what would it might look like if we were to drive along our road? Well, we can do that here. And then if we want to put together our documentation, well, we can jump over into this. So this is our multiplot. This is where we put together our drawing packages. Now, if we were for some reason wanting to start entirely from scratch, we could come in here and say, I want to use this size sheet and I want to add in my various views. We could build it out, build out our title blocks, and we could save that for use on future projects. Now, if we didn't want to start from scratch, we could come over here and we could say, well, I want to bring in a plan over profile that's already been largely formatted, and I could start editing that as a starting point instead. But if I've already got my document set up with my various chapters, reflects the way I'd like to typically present it, well, we could just hit that, and now I've got my title page, my plan over profile, various data tables being populated. I've got my sections, and away we go. So it's really easy to do your documentation, and then we can plot it. Now, if we're looking for more of a digital output, we could come up here, file, save as, and well, we could save it as a location file, which is that DSNX format. But if we wanted something to go back and forth with other environments, we could hit file, save as, maybe land XML for construction staking, maybe a shape file for sharing with the GIS folks in our organization, maybe just a KMZ to make it nice and easy for, well, anyone to pop it open and see what they're dealing with in Google Earth. So all of our kind of standard formats are covered there: DWG, DXF, DGN, text, etc. So really easy to write this information to external files. And with that, I think we've got it cased. We've got kind of that high-level overview of, well, a design process if we're going with the manual approach. So with that, I'll pass it back to Erin.
Excellent. Okay, so today's webinar, as we introduced, we're going to be doing essentially 2 demonstrations. So the first one focused on total station, creating that tin surface, alignment editing in the more manual side of things. And now we're going to show you kind of, I'm going to say our optimization workflow. So here we're going to bring in a larger resolution data set. This could be DEM, this could be LiDAR, this could be drone data, larger point cloud. And then we're going to show you how we can use a couple of different tools in the software really to help us improve the efficiency of our design, reduce the volumes of earthworks. And this type of workflow has sort of, I'm going to say, two key elements. The first one is going to happen in the terrain module. And this is where we're going to leverage Path Explorer. Now, Path Explorer, super cool new tool that we introduced last year in our software. It is great at figuring out where to put a road on a landscape. So if your road is heavily constrained and you essentially know its horizontal position, this isn't the tool. But for example, if you need to create a new road to connect a community, to get to some type of resource, this tool is phenomenal at being able to quickly explore, hundreds of millions of possible options to help you find low-cost, constructible candidate solutions. So Matt, as he goes into this next example, he's going to talk a little bit about obviously setting up that terrain model with the high resolution data, and then he's going to give us a quick introduction to Path Explorer to figure out where to put that road on the landscape. For this, we can include lots of different variables, such as your minimum maximum grades, your minimum curvature, as well as if you have any other shape files or areas that you want to denote as no-go zones or environmentally sensitive zones, or perhaps you just want to minimize the amount of stream crossings. This is something that that tool can do. So we'll include Path Explorer, and then the other step that we're going to include in this workflow that's very different, that reduces some of that manual work but improves our efficiency, is all about vertical optimization. So in that last example, Matt talked us through how we could create that vertical profile with the mouse. He added curves manually. Well, we can do all of that with the click of a few buttons to at least get us a really, really good starting point for our vertical alignment. So let me explain a little bit about what this tool is doing and its significance. So of course, our profile, we start with our ground. We're going to design a vertical on it. Then we're going to optimize that vertical. So what this tool is going to do, it's going to look at all the little cuts and fills and material movement across that profile, and it's going to use a whole bunch of very fancy math in order to minimize those cuts and fills and the material movement costs. And really the result of this, and I'm sorry, it's a dreadful example there through the graphics, but the idea here is that all those little changes, even if it's moving your alignment vertically, even 10 centimeters up and down in some spots, all those changes have a tremendous impact to your subgrade earthwork costs, somewhere in the magnitude of, say, 15 to 25% reduction, of course, more depending on the design speed of your road and its class. So we're going to now step into example number 2, bring in some high resolution data, include path exploration, and then include vertical optimization in that process. So Matt, coming back to you for example number 2.
All right. Largely going to just start from scratch and work through a project here without breaking it up into incremental steps. And of course, I will talk my way through it just to hopefully make it easier for folks to follow along. And I'll explain the stuff that may be new, but I won't dwell on anything that would have carried over from the last example. So this example, I'm going to bring in a high-res DEM. And we'll do that here. And we could thin the data on import if we'd like. We could thin it to, or limit the data to an area of interest if we'd like, or we could reduce the resolution. In this case, I'm going to reduce the resolution just a bit, given how large the file actually is here. And so I'm going to do that just really quickly, and then we'll continue along. So the similarities between the last example is, well, it's ultimately topo data or survey data, but this one, each point wasn't collected by a surveyor. We've got, well, in this case, it was collected from a scanner. So I've got 8 million points in my model. I'm going to click this, and I'll leave the contours off just for now. We'll turn those 8 million points into a surface. And we'll have a look at what that surface looks like in the 3D view. So we can see we've got, well, channels, looks like some roads. Now this is fairly benign terrain, except for obviously the really incised channels. So if I really want to see my relief, I may stretch this out a little bit. So I'm going to just exaggerate my vertical in the 3D view by a factor of 5. So we can see where the existing roads are, and obviously in this area there's very few existing roads. So that 3D view makes it nice to understand what we're up against. We may also want to visualize other information here. So we could, of course, it's projected information. So we could connect to a web map tile service if we like and bring in information from either Google, Bing, etc. If we already have that information, and well, I do, so I'm not going to re-download it, but we can bring it in and add that ortho imagery as a background. Now that's great for just visualizing what we're dealing with. If we wanted to know kind of maybe where the streams are, for example, well, we could, if we had that data in a variety of formats, we could of course just insert it, but I don't have that. So instead I'm going to use our hydrology tools. I'm going to tell the software to, well, figure out where the streams likely are based off of a minimum drainage area contributing to a point. We'll run that and we'll very quickly get, well, a series of vectors for our streams and a series of polygons for our ponding areas. So haven't really done any of the design stuff here, but it's really easy to get a good understanding for what we're dealing with. Now for this particular example, I am going to bring in a shapefile just rather than picking somewhere arbitrary. I want to bring in a shapefile, and I'm going to just use this to visualize where I want to start from and where I want to go to, and make it a little easier for people not right in front of my computer. Those of you on the other side of the screen, we can see that, okay, I've added a point here. I've added a point here. So I want to go from this pre-existing road all the way over to that pre-existing road. So I'm going to take those 2 points, I'm going to join them. And I'll drape that just so it's a little easier to see. And I can tell the software, instead of me manually moving my alignment around like we did in the last example, I can tell the software to figure it out. If I know where I want to start and end, we can say, well, let's assign our minimum curvature. We can say I want to have 5 options or X number of options. We can put in some information for our geometry. So 12-meter road, cut and fill slopes. I want to go with max grades of 12%. I've got my costing information here. And then if I want to tell it that at the start of my road, I want it to be pointed from in that direction, but at the other end of my road, I want it to come in from that direction, we can. And lastly, aside from just that dirt cost, if there's anything else we'd like to consider, so if there were no-goes areas that we had polygons to say, don't put my road in there, we could add those as construction zones. We could also add polygons or polylines where we tell it that the software is going to, well, recognize that it costs more or less than our default values. So for that, I'm going to use our streams as an example. So obviously we have the dirt cost of well, building our road, but there's also the crossing costs. So I'm going to say each one of these streams is going to cost $5,000. Picking something arbitrary, we could split it up in varying levels of detail, so the bigger streams cost more, but we'll keep it simple here. And then we'll hit OK, and we'll let this thing go. Now, with this, it's not instantaneous, but it is very quick. So we're going from one point to another point. It's going to search for a while, and then it's eventually going to say, well, I'm likely to improve further. And once it says that, we can hit cancel, and we've got our solutions. So these solutions, we told it give us 5 solutions. All 5 of these lines are going to be within 15% of the cheapest, but they're the most spatially diverse. And if we are interested in how they rank against each other, well, that one's our cheapest, just given the number represents the expected cost given the parameters we've defined. So that is our preferred option. But there's no reason that we might not want to look at others. So this is kind of getting it set up so we can, 1, understand the problem, 2, figure out our initial alignment. And I'm going to save this, and I'm going to take this line rather than a surveyed center line. We're going to use that to start our location design. So we'll let this save, and we'll jump into the other module. All right, so same idea as before, opening up location. We're going to reference that file. We're going to use that Path Explorer feature as our initial alignment. We'll click zoom to extent so we can see what we're up against here. And we are going to, well, do some of the same things that we've already done. And that is, well, we probably want to reduce this down to a series of curves and tangents. So we'll take that. So our Path Explorer solution is considering the problem in 3D and adhering to our curve constraints. But we'll take that polyline that adheres to our curve constraints and actually convert it into a proper alignment, series of curves and tangents. And we can let this go. It's just going to continue to, well, reduce the deviation from our original. I'm going to hit cancel here. We'll take the best solution it's found so far. So we can see, well, we are in business. We've got a good line here, and we've got our cross-section geometry set up the way we'd like. I'll just lift this first station up a little bit more so it's on ground. And well, we can avoid moving things around and adding that vertical alignment manually. We can come over here and we can say, well, let's tell the software to figure this out for us. We told it we want a max grade of 12%. We can put in whatever we'd like for crests and sags. and adding control points. So if there's anywhere at a particular station that we want to be at a particular elevation, we can add that in, and then we can hit process and let this thing go. And what it's going to do is find the optimal vertical alignment that's considering our earthworks costs and design criteria. And again, it's one of those things that's not instantaneous, but for what it is doing, it's extremely quick. And yeah, we'll watch this plug away, probably less than a minute. And then we'll have our road geometry sorted. And it shouldn't be too much longer here. And there we are. So we've got, if we look at that mass haul is moving very little material for this class of road. We can kind of go along our alignment. We could use all those tools in the toolbox that we've previously covered for reviewing and summarizing. We could add in our culverts, etc., and throw together a documentation, and voila, instead of doing everything manually, we've got the computer doing a lot of the heavy lifting for us. And well, in a matter of minutes and well explaining, we've got about 9 kilometers of road tackled. So with that, I'll pass it back to Erin.
Excellent, thank you, Matt. Okay, so in the last hour, we have obviously had a quick introduction to RoadEng. We stepped through a high-level workflow for road design using RoadEng. We did 2 projects, one using total station and one using that sort of higher resolution point cloud data. We created horizontal and vertical alignments, we created construction documentation, and then we also introduced optimization tools. So we have covered a lot of content in the last hour, and really, you know, what do you do from here? How do you translate some of these things that you've perhaps learned into actionable next steps? And I think really that is a wonderful opportunity to introduce our local partner, because really these are sort of that connection, or say bridging the gap between technology and the actual local users. And so for that, I'd love to, turn it over to Bonnie, the Vice Chairman from KeyCam Technologies, talk a little bit about sort of their role that they play in Nigeria and into West Africa, as well as some next steps available for you if you'd like to learn more or like to get a bit engaged. So for that, Bonnie, over to you.
Yeah, thank you so much. Yeah, thank you so much, Erin, for a great presentation. And I'm sure those who have been able to follow up must have seen how easy it is to use the RoadEng and the various options that are available. We are the local partner for Softtree, and we are here to provide local support and training. We'll also be organizing, and we have been organizing workshops and product demos. We're here, and also here to work with you, our partners and our end users, as the case may be. New features as they come in, we are there. The price is also an issue, which is a very big challenge for some of the engineering companies and organizations. The prices are competitive compared to competition that you can get from anywhere, I can tell you that. Then the logo presence here and the excellent and wonderful support of Softtree is unbeatable. Some of the existing users in Nigeria are actually, amazed with the kind of support they get from Softtree. So we are here to support you. We're here to work with you from beginning to the end. Not only that, also to empower your internal team, to ensure that they optimize the value of these applications. So we want to tell you that we're here for you. Anytime you want us, good pricing, good support, training, empowerment, every side of it, to ensure that you get value for your investment in RoadEng or any other of the other applications, the add-ons, as the case may be. We are based in Lagos and we operate across the West African zone. We are into software, and this is the only engineering software we sell. And we are happy with Softtree regarding their application. We also have other solutions around cybersecurity, training, and consulting services. And we'll be most delighted to see how we can support you. Anything that is required, please let us know, whether you need demo licenses you want to use for 7 days, 14 days. We are here to do that ourselves and our team.
And with that, thank you, Matt. Thank you for being here and coordinating with us, Bonnie, and to the KeyCam team. We appreciate everyone that joined us here today live, and for those of you joining us off of YouTube, thank you very much. We do host these webinars every 2 to 3 weeks, so yeah, be sure to check the calendar of links that'll be included in your follow-up email. Join us for another one. We love connecting about the software. And with that, thank you, everyone. Have a wonderful day. And Bonnie, maybe some parting remarks.
Thank you. Thank you so much, everyone. And just like Erin pointed out, the webinar section will be shared so that some of the participants could also take their time to listen to the entire section once again. Thank you.
Thanks,
Enjoy
everybody.
your weekend.
Thanks, everyone.
Bye.